Good day. So today we're looking at the alkenes. And as you can see, the alkenes, they have a double bond. Okay, that is the functional group for alkenes, that double bond between the two carbon atoms. Okay, and you will also note that these alkenes, we say that they are unsaturated. Why are they unsaturated? Because they have less hydrogen than the alkane. And why is that? Because they have a double bond. Because they have a double bond, that means that they have fewer hydrogen atoms. Okay? So this double bond can also be broken and more atoms can be added. Okay? Now the ending is E and the general formula for alkenes would be CnH2n. Example is your ethane. Okay, ethane, two carbon atoms and four hydrogens. So now we have cracking. I know you were wondering, where do these alkanes come from? So here you have the source of alkane, which is cracking. So here you have a 7 carbon atom. Okay, after it has been cracked, you're going to have a shorter chain alkane and also an alkane. Okay, and the reason why cracking occurs is because these long chain hydrocarbons, they are not useful at all. So in order for us to get more useful products, we want to do this. We want to crack the alkane. Okay, and what is needed is you're going to need your high temperature. Okay, and you're also going to need a catalyst. So the catalyst that you're going to need is aluminum oxide. Okay, so we had 7 carbon atoms here, and when we cracked it, we ended up with a shorter chain alkane, which is 5 carbon atom, and then we also ended with a double bonded alkene, which is the ethane. That's it. So now we're going to look at the reactions of alkanes. So we have this ethane here, and we have a bromine being added to the ethane. And when the bromine is added, as we can see, the double bond breaks, okay? And then we add the Br, okay? We just add the Br. First step is you break the double bond and then you add the two bromines, okay? And this reaction is called halogenation. So you're adding, what are you adding? You're adding a halogen, right? So you have the word halogen and then at the end you have ation, A-T-I-O-N. That's it. So you can also be asked to give the symbol equation, okay? And the symbol equation is just your molecular formulas, okay? So you have 2 carbons and 4 hydrogens, okay? And then you have Br2, formula for bromine. And then you have this organic compound here. What is this organic compound? Okay, what's the structure for it? You're going to place your carbons, your hydrogens, and then you're going to place your bromine or whatever else last. So I have 2 carbons, I have C2, I have 4 hydrogens, 1, 2, 3, 4, and then I have my 2 bromines. That's it. Easy. Now your next reaction here, so you have now an ethane and you're going to add, you can also add a hydrogen to an ethane, but you will need a catalyst, that is nickel or platinum. In the presence of the catalyst, what's going to happen is you are going to have an organic product now. Same thing again, the double bond breaks, you're going to add your 2 hydrogens, easy. What's the name of this reaction? Since we're adding hydrogen, remember we just place that item that we're adding, so we're going to place it as hydrogen and then we're going to put ATION at the end of it. So that's hydrogenation, okay? And you can also have your symbol equation. Now we have 2 carbons and 4 hydrogens for ethane plus H2RO, and then I have 2 carbons and then I have 6 hydrogens, okay? Now I have an ethane molecule. Okay, looks familiar? Good. Next, you have this right here. So now your ethane, you could also add a HBr to that ethane. And again, formula for ethane, C2H4 plus HBr. And my product is going to just be me adding the H and the Br, breaking my double bond. Now, for me to get that formula, I'm going to just add up the carbons, two carbons, C2H5, because I have 1, 2, 3, 4, 5 hydrogens, and then my Br. And this would be called, the reaction for this is going to be called hydrohalogenation. I'm adding a hydrogen and a halogen, so hydrohalogenation. Next, next you can add water. You can add water to ethane, but you will need a catalyst, which is phosphoric acid, H3PO4. In the presence of this catalyst, what's going to happen is, again, we know that that double bond is going to break, and then we're going to add the H and the OH. We know that, okay? And my symbol equation for this is just my carbons. I added my carbons, C2H4 plus H2O, which is the formula for water, RO. Then I'm going to count out my carbons again, C2, H5, 1, 2, 3, 4, 5, and then OH. And the name of this reaction is called hydration. Whenever you add water, it is called hydration. Easy. Now remember the first reaction we had halogenation. Now if that halogen is a bromine, bromine is brown in color. And we take advantage of this and we use it to test for alkanes and alkanes. Okay? So bromine is brown in color, but when we place it in an alkane, as you can see, the brown color of bromine remains. But when we place it in an alkene, what do we notice? There's a discoloration of bromine. Okay? So now remember when we talked about polymers? Now one important use of polyethylene would be in plastics. Okay. Now we have a question that we are going to go ahead and answer. And this is a paper 3 question, but we got this, okay? It's found on page 184 in your booklets. But first thing we do when we get a question is we read the question. It says, ethylene is a naturally occurring compound that speeds up ripening of fruits and vegetables. And it says, draw the structural formula for ethane. We know that ethane is an alkane, so it has a double bond. And we know that F means that it's two carbon atoms. So what are we going to do? We're going to draw our two carbon atoms with a double bond between them, okay? And then we are going to make sure that each of our carbon atoms has 4 bonds by adding in some hydrogens, okay? So 2 bonds between the carbons means that that's 2 bonds already. So we just need how many more hydrogens? 2. Good. So each of my carbons now need 2 more hydrogens to make sure that it has its full 4 bonds. That's it. You just drew ethane. Good job. So next it says write a chemically balanced equation for the reaction, and we got this. Most of the time when you write these equations, they are already going to be balanced, okay? Once your formulas are correct, it's going to be balanced, okay? So it tells us to write a chemically balanced equation for the reaction. So we are just going to go ahead and formula for ethane, okay? Our formula for ethane is C2H4, okay, plus hydrogen, which is H2, RO, C2H6, okay? That's it, okay? So that's it. So all we did was we just added 2 hydrogen to this ethane, and you got C2H6, and instead of having an ethane, now you have an ethane. And remember, there is a catalyst for this, and that is nickel or platinum. That's it. Now, it says, describe what is seen when ethane gas is bubbled through bromine water. Okay, do you remember what it's saying? Okay, let's look at the picture on the left hand side. What do we see? An alkane. Good. You see there's a rapid discoloration with an alkane. You stated what the information was, and then you ended it. Okay, don't run on, because you don't want to run on with something that's incorrect. Okay, so say what you have to say, and then end it. Now, next question says, okay, we'll look at this question on the next slide. So here again, we have another question, and as you can see, they're giving you a lot of extra information. It is your goal to go through the information, and then pick out relevant information, okay? So tetrafluoroethane, so they're giving you a lot of things just to try to confuse you. Tetrafluoroethane can be polymerized to Teflon, which provides a good coating for making non-stick pots and pans. This might be new information for you, okay? You might not have known that, and that's okay. But what they're telling you is that the structural formula for a monomer of a tetrafluoroethane is shown. Using 3 monomers of tetrafluoroethane, draw to show the polymerization of tetrafluoroethane to Teflon. So, key thing, it says for you to use 3 monomers of this tetrafluoroethane. So this is what we're going to do. We're going to add 1 monomer. So we're going to have 1 monomer here. Okay, so this is my, remember this is a monomer. Okay, we're just going to be combining with many monomers to give you the polymer. That's polymerization. So it says you need 3 monomers. So this is 1 monomer. So I'm going to add another monomer exactly as they drew theirs, you draw yours. And now I'm going to add a 3rd monomer. Okay, I'm going to have my arrow, and then what I'm going to do is I'm going to be combining these little monomers. Okay, when I combine them, I'm dropping the double bond. Okay, and that's it. Okay, just drop the double bond, and now I have a long chain polymer. Okay, exactly as my monomers looked, my polymer is going to look, but then I'm not going to have the double bond anymore. Okay, so that's it. That's all they want from you. And then how do we name this? We just put poly in the front of it. So it'll be poly tetrafluoroethane. That's it.